Welcome to Chapter 7, Functions. As programs grow longer, they become harder to read and debug. Functions solve this by letting us break a big problem into smaller, self-contained, named pieces of code that each solve one specific task. Functions provide four major benefits. First, they make code more readable. Second, they reduce code length because the same logic does not need to be written multiple times. Third, they make debugging easier. And fourth, they enable team collaboration by allowing different developers to work on different functions. Modular programming is the technique of dividing a program into separate, independent blocks. Consider a tent manufacturing company computing costs. Instead of one long program, they break it into three functions: one for the cylindrical area, one for the conical area, and one for the post-tax price. Python has three categories of functions. Built-in functions like print and len are always available. Standard library functions like math.th must be imported, and user-defined functions are written by you to solve problems specific to your program. To define a function in Python, start with the keyword def, followed by the function name, parentheses, and a colon. The body of the function is the indented block that follows. Importantly, a function must be defined before it is called anywhere in the program. Defining a function does not execute it. The code inside the function only runs when you call the function. To call a function, write its name followed by parentheses. For example, writing addNum triggers the execution of the addNum function. Parameters are variables listed in the function definition that act as placeholders for incoming data. Arguments are the actual values passed during the function call. When you call sum squares of 5, the value 5 is the argument that gets assigned to the parameter n inside the function. A function can accept multiple parameters separated by commas. For example, def fullname accepts first and last as two parameters. When calling the function, you provide two arguments in the same order: first name, then last name. The function then concatenates them. A default parameter has a predefined value that is used when the caller does not provide that argument. For example, def mixed fraction with deno equal to 1 means that if you call mixed fraction of 9, deno automatically takes the value 1 without you needing to specify it. There is an important rule for default parameters. They must always appear after all non-default parameters in the function header. Writing def calc interest with principal having a default before rate, which has no default, is incorrect and will cause an error. The return statement serves two purposes. It sends a value back to the caller, and it immediately transfers control back to the calling code. Functions without a return statement are called void functions and implicitly return the special value none. Consider the function calcpow that accepts a base and an exponent, computes the result, and returns it. The calling code stores the return value in a variable, answer equals calcpow of 5 and 4. The return value sit5 is now stored in answer and can be used freely. Based on parameters and return values, Python functions come in four forms. A function can have no arguments and no return, no arguments but a return, arguments but no return, or both arguments and a return value. The right form depends on what the function needs to do. The flow of execution changes when functions are involved. When Python hits a function definition, it remembers it but does not run it. When it encounters a function call, control jumps into the function. After the function completes, control returns to the line right after the call. Scope refers to the region of a program where a variable can be accessed. A local variable is created inside a function and only exists while that function is running. A global variable is defined outside all functions and can be accessed anywhere in the program. Local variables are created fresh each time a function is called and destroyed when the function ends. This means two separate calls to the same function do not share variable memory. Whatever you compute inside a function stays inside unless you explicitly return it. Global variables are accessible from anywhere in the program, including inside functions. However, if you try to modify a global variable inside a function without declaring it, Python treats it as a new local variable instead. The function sees the global value but cannot change it without explicit declaration. To modify a global variable inside a function, you must declare it using the global keyword. Writing global x at the top of a function tells Python that x refers to the global variable, not a new local one. While this works, overusing global variables makes code harder to understand. Python comes with a rich standard library containing hundreds of pre-built functions organized into modules. To use them, you first import the module. For example, writing import math gives you access to mathematical functions like square root, power, floor, ceiling, and constants like pi. There are two ways to import. Writing import math means you call functions as math.scort. Writing from math import scort means you can call scort directly without the module name prefix. The random module provides random.randint to generate random integers between two values. The math module contains many useful functions. Math.scort returns the square root. Math.pow raises a number to a power. Math.floor rounds down to the nearest integer, and math.ceil rounds up. The constant math.pi gives you the value of pi to many decimal places. Python also provides built-in conversion functions that do not require importing. The function len returns the length of a string or list. The function str converts a number to a string. The function int converts a string or float to an integer. The advantages of user-defined functions are significant. Reusability means you write the logic once and call it many times. Readability means the program is organized into clearly named sections. And maintainability means you fix a bug in one place and it is fixed everywhere the function is used. Recursion is a technique where a function calls itself. A recursive function must have a base case that stops the recursion, otherwise it runs forever. The classic example is factorial. Factorial of n equals n multiplied by factorial of n minus 1, with factorial of 0 equal to 1 as the base case. To summarize Chapter 7, functions are named blocks of reusable code defined with def. They accept parameters, optionally return values, and have their own local scope. Python's standard library provides powerful ready-made functions through importable modules. Functions are essential for writing organized, efficient, and maintainable programs.